Hello students, welcome you to this video. In this video, I am going to teach you MCQs from the 9th chapter, Applications of Integration, right? So first you must be thorough with all the applications, all the formula in integration, then the properties you need, right? If you know that, definitely you can do these objective questions very easily. Okay, let us do one by one. Now the first question, the value of integral 0 to 2 by 3 dx by root of 4 minus 9x square. So you know there's a formula integral dx by root of a square minus x square. What's the formula? Sin inverse x by a, right? Sin inverse x by a. Don't write 1 by a into, only for the tan inverse formula 1 by a tan inverse x by a. Here it is only sin inverse x by a. Limit, okay, here, okay, this is actual formula plus c. But now in this question, integral 0 to 2 by 3 dx by 4, that is 2 square, minus 9x square, you can write it as 3x the whole square of dx. So now this is of that type, right? So what's your answer? Sin inverse x by a, instead of x what you have? 3x, right? 3x by a value 2, apply the limit. At the same time, instead of x what you have here? Instead of x we have 3x. So its derivative you write in the denominator. 3x derivative 3. Don't forget to write that 1 by 3. So now we apply the limit, that is 1 by 3 into sin inverse. First you give the upper limit 3 by 2 into, for x you write 2 by 3, minus sin inverse 0. Sin inverse 0 is 0 only, right? So that is 0, you can leave. Here 2 cancel, 3 cancel. So sin inverse 1, sin which angle is 1? 90, pi by 2. So 1 by 3 into pi by 2. So your answer is pi by 6. That is option number 1. Now let's move on to the second question. Integral minus 1 to 2 modulus x dx. So whenever you have modulus, you have to be very careful. It's a very simple question. Modulus x equal to x if x greater than or equal to 0. And modulus x is minus x if x is less than 0, right? Here the interval is, so integral from minus 1 to 2. Minus 1 to 2. So when x is greater than or equal to 0, okay, 0 is somewhere here. When x is greater than or equal to 0, modulus x value x, and when x is less than 0, it is minus x. So minus 1 to 2, we don't have a single function, right? So it breaks at 0. So it's split into 2, minus 1 to 0 plus 0 to 2. So you can write it as integral minus 1 to 0 minus x dx plus integral 0 to 2 x dx. Very simple integration. That minus sign, if you want, you can take it outside, or that minus you can adjust with the limit. Instead of minus 1 to 0, you write 0 to minus 1, like that also you can write, okay? So minus I am adjusting with the limit. So x integration x square by 2, the limit instead of writing minus 1 to 0, I am going to write 0 to minus 1. Plus x integration x square by 2, the limit 0 to 2. So there is one property, right? Limits can be interchanged, just to put a sign minus. So here first you give minus 1, when you give minus 1 square, it is plus 1, 1 by 2, minus when you give 0, it is 0. Plus when you give 2 here, 2 square, 4, 4 by 2, minus when you give 0, it is 0. So 2 is LCM, 4 plus 1, 5. So it is 5 by 2. That's your answer. That is option number 3. Now let's move on to question number 3. Look at the third question. So we have a lot of properties. See, question looks little lengthy one, right? What is given here? Integral 0 to pi e raised to cos square x into cos cube 2n plus 1 of into x of dx. So we want to find the value of this, right? So what I am going to do, I am taking this part as say fx. So we take that part as fx. So there is a formula 0 to 2a f of x dx is equal to 0 when f of 2a minus x is f of x, sorry, minus f of x, right, is minus f of x. When f of 2a minus x is fx, its value will be 2 into 0 to a, given 0 to 2a, now we write 0 to a fx dx. Okay, so this is a property. So in this case, so we are going to check this condition. Which condition satisfied? If the first condition satisfied, it's very simple, right? Just you put the answer as what? 0. Let us see. So the limit must be 0 to 2a. So this is our 2a. So I'm taking f of x. Let f of x equal to e raised to cos square x into cos cube 2n plus 1 into x. Right? This is what fx. Now we find f of pi minus x, right? F of pi minus x. So 180 minus x. What is cos 180 minus x? Cos 180 minus x. See, 90, 180 is on the line. Minus x means it will come back to the second quadrant. Second quadrant only sign is positive. So cos 180 minus x is minus cos x. But here the first one you see e raised to cos square x, right? So for x you put 180 minus x, cos 180 minus x is minus cos x, but the whole square is there, so it becomes plus, no problem. You are getting cos square x. But in the second case, instead of x you give 180 minus x. So cos 180 minus x is what? Minus cos x, but the whole cube is there. So minus 3 times it becomes minus, right? So overall you will be getting a minus cos cube 2n plus 1 of x. So this is actually minus of f of x. So the question I am taking it as I. So you can, since this condition satisfied, your answer is equal to what? 0. So therefore I equal to 0, and that is option number 3. Now let's move on to the fourth question. Integral minus pi by 2 to plus pi by 2. Normally, if the integral is minus a to plus a, we check whether the function is odd function or even function. If it is odd function, the answer 0. If it is even function, 2 times 0 to a, right? But here, minus pi by 2 to plus pi by 2, sine is an odd function, but the whole square is there, right? So it becomes even. Cos x is even function. Totally it is an even function. You can write it as 2 into integral 0 to pi by 2 sine square x into cos x dx. Now how can you integrate this? We have to use substitution because sine and cos are there. Sine derivative cos, cos derivative minus sine, right? Here sine square is there. Take that as t. So it becomes t square, right? So you take sine x equal to t. So sine x derivative cos x dx is equal to dt. So whenever you use substitution, you have to change the limit also. Here what limit given? 0 to pi by 2. That is the limit of x. But we are converting into t, right? So when x equal to 0, t equal to sine 0. Sine 0 is 0. When x equal to 90, when x equal to pi by 2, t equal to sine pi by 2. So sine 90 is equal to what? 1. So you are getting 2 into integral 0 to 1 sine square x, that is t square, into cos x dx, that is dt. That is 2 into t square integration t cube by 3 limit 0 to 1. So that is 2 into upper limit you give 1 by 3 minus lower limit is what? 0. 0 by any number is 0. So your final answer is what? 2 by 3. So that is option number 4. Okay, now let's move on to the fifth question. Look at this fifth one. Question looks little lengthy one, right? But it's a very simple one. Before doing this sum, please listen. inverse trigonometric functions, tan, inverse and all there, right? Please listen. Suppose you have tan inverse, say 2 by 3. Can be written as, you can take reciprocal, 2 by 3, you can write 3 by 2. At the same time, tan reciprocal also you should write. Tan inverse, so you write cot inverse, because tan reciprocal is cot, right? Cot inverse, don't write 2 by 3, you write 3 by 2. Like that, sine, you can convert it into cosecant. Sine inverse, you can write cosecant inverse. Cos inverse, you can convert it into secant inverse, okay? And you take the reciprocal of the value given there also. And another property what we are using here, tan inverse x plus cot inverse x. The answer is pi by 2. Like that you have another two results, right? Sin inverse x plus cos inverse x is pi by 2. Secant inverse x plus cosecant inverse x also pi by 2. If you know this, you can do the sum very easily, okay? So listen, so integral, question is integral minus 4 to plus 4. Tan inverse x square by x raised to 4 plus 1 plus, next you see, this is x square by x raised to 4 plus 1. The other one is exactly the reciprocal, right? So what I'm going to do, to make them same, I'm going to take reciprocal. So tan reciprocal cot. So cot inverse, you write the reciprocal, you'll get x square by x raised to 4 plus 1 of dx. Now you see that both the values are same, right? So tan inverse x plus cot inverse x. So both these x are same. So tan inverse x plus cot inverse x, the answer is pi by 2. The format should be there. Both the values should be same, whatever it is. So here the answer is pi by 2. So you are getting minus 4 to 4 pi by 2 dx. So pi by 2 is a constant. Integral dx is x. The limit is minus 4 to plus 4. So what you are getting here, that is pi by 2 into, first you get the upper limit 4 minus minus 4, it is plus 4. So 8 pi by 2. Cancel 2 table, you are getting 4 pi, right? So you are getting, which is equal to 4 pi, and that is option number 4. Okay, now let's move on to the next question. Question number 6. Look at this question. Again integral minus pi by 4 to plus pi by 4. Minus pi by 4 to plus pi by 4. Numerator 1, 2, 3, 4, 5 terms are there, right? By cos square x. So minus pi by 4 to plus pi by 4. Integral minus a to plus a. Normally we check whether it is odd or even. Denominator cos square x even. Numerator x raised to 7 odd, x raised to 5 odd, x cube odd, x odd 1. There is no x at all, right? So if you split every into 5 terms, listen, then you can understand very easily. Minus pi by 4 to plus pi by 4, 2x raised to 7 by cos square x dx, minus integral 3x raised to 5 by cos square x dx, plus integral minus pi by 4 to plus pi by 4, 7x cube by cos square x dx, minus integral minus pi by 4 to plus pi by 4 x dx, x by cos square x, right? And the last one is integral minus pi by 4 to plus pi by 4, 1 by cos square x dx. Now you know for odd function the value 0. The first one you see denominator is even, numerator x raised to 7. If you, instead of x, if you put minus x raised to 7 is minus of x raised to 7. So f of minus x is minus f. So this is an odd function, so the value is 0. Second one, denominator is even, but numerator is x raised to 5, odd function 0. Third term, odd function. Fourth term also odd function. So first 4 terms 0. So 0 plus 0 plus 0 plus 0 plus. Next one is even function. You can write 2 into integral 0 to pi by 4. Take it to the numerator secant square x. So integration will be easy, right? That is 2 into secant square integration tan x. Limit So the limit is 0 to pi by 4, not pi by 2, right? So secant square x integration tan x, limit 0 to pi by 4, 45. So that is 2 into tan 45 is 1 minus tan 0 is 0. So the answer is 2. So that is option number 3. Now let's move on to question number 7. Listen to the 7th question. F of x equal to 0 to x t cos t dt. It's a very simple question. What they asked? df by dx. df by dx. So here, what method what you have to understand here is differentiation and integration both are inverse operation. So integral dx. Integration derivative cancel. Your answer is what? X. Okay. So integral dt. Your answer is what? T. But if they give the limit 0 to x, for instead of t you put what? X. So your answer is what? X in that case. So here also df by dx. F of x equal to integral 0 to x t cos t dt. df by dx there. So you have to differentiate it. So the integration part get cancelled. You are getting t cos t. The limit only what? 0 to x you have to apply. First you give the upper limit. Your answer is x cos x, right? X cos x, and when you give 0 it is 0. So your answer is x cos x. That is the third option. Now let's move on to the 8th question. Area between y square equal to 4x and its lattice rectum. You know what is lattice rectum? Perpendicular focal chord. Through focus you draw a perpendicular line. So that is called lattice rectum. So y square equal to 4x, first type parabola, right? This is a first type parabola. And its lattice rectum. So here 4a is 1, right? 4a, it is 4. So this is a value 1 you will get, right? So y square equal to 4x, y square equal to 4ax. So 4a is 1. So 4a is 4. So a equal to 1. So here a value it is 1. So through 1, if you draw a perpendicular line, so that line is called lattice rectum, right? Direct method you will get this area. Like that, one more portion you multiply by 2. So I'll teach the direct method, but there is an easy method, so that any parabola let them give, you can write the answer in a single step. Okay, but I'll teach you the direct method also. It will be useful for 2 marks, 3 marks also. Okay. So limit 0 to 1. X varies from 0 to 1. So find the area in the first quadrant, but like that one more portion is there, so you have to multiply by 2. So required area is 2 into area formula integral a to b y dx, right? So that is 2 into integral 0 to 1 y dx. What is y? You can find y from here. Y square is 4x. So y equal to 2 root x, right? So 2 into root x. Root x means x raised to half. That is 2 into 2, 4. You take that 4 outside. See what you are getting. X raised to half. Integration. Add 1 to the power. X raised to 3 by 2 by 3 by 2. Limit 0 to 1. So the 2 goes up. 4 2s are 8. 8 by 3. Limit you give. When you give 1, 1 raised to 3 by 2, it is 1. Minus 0, it is 0 only. So your answer is 8 by 3. Right? That is option number 3. But now I'll tell you the direct method. For competitive exams and for objectives, you can use this method. Suppose a parabola y square equal to 4ax and cut by the lattice rectum, then the area is equal to 8a square by 3. So just a value substitute. In this case, a value is what? 1. So it is 1 square, 1, 8 by 3 is the answer. Okay, suppose they give, say, y square equal to 12x. So this is our 4a. So 4a is equal to 12, a value 3. So just you put a value 3, 3 square, 9, and then you simplify. Okay, that's all in a single step. You can do that. Now let's move on to the 9th question. Integral 0 to 1 x into 1 minus x raised to 99 dx. So here also there is a formula. Direct method is also there. I'll teach both. Okay, I'll teach the direct method first. We have a substitute. We have a property, right? So we have integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. If you apply this property, the question become integral 0 to 1. What do you do here? Wherever x comes, you put a minus x. So x become a minus x become x. Here instead of a, we have 1. So wherever x comes, you put 1 minus x, and for 1 minus x, you write x. So x become 1 minus x, and that 1 minus x become x. This 1 minus x raised to 99 only the problem, right? If you expand, you will get 100 terms. How can you find that, right? But x raised to 99 is not at all a problem. Now we multiply term by term, integral 0 to 1. 1 into x raised to 99, x raised to 99, minus x into x raised to 99, it is x raised to 100 dx. Now we integrate it. X raised to 99, x raised to 100 by 100, minus x raised to 100 integration, x raised to 101 by 101. Limit 0 to 1. First you give the upper limit 1. 1 raised to any number is 1. 1 by 100 minus 1 by 101. When you give 0, both the term becomes 0. Take LCM, 100 into 101. So this 101 comes here, minus 100. So your answer is 1 by 10100, right? So this is your answer, option number 2. But what is the direct method? So another method is, so there is a formula, integral 0 to 1, integral 0 to 1 x into 1 minus x raised to n dx. 1 by n plus 1 into n plus 2, that's all. 1 by n plus 1 into n plus 2. In this case, same type only, no? Instead of n, what is given? 99. So your answer is 1 by 99 plus 1, 100 into 99 plus 2, that is 101. Your answer is 1 by 10100. Okay, you can do like this. Now let's move on to the 10th question. I am taking the question as I. Let I equal to integral 0 to pi dx by 1 plus 5 raised to cos x. Take it as equation number 1. Limit 0 to a. So we use the same property. We have integral 0 to a f of x dx is integral 0 to a f of a minus x dx. So what you do here, wherever x comes, you put pi minus x. So you can say again I equal to, write the limit as it is, integral 0 to pi dx by 1 plus 5 raised to cos x. Cos, don't write x, you write pi minus x. But you know cos pi minus x is minus cos x. So 5 raised to minus cos x. Now we are going to simplify this. So I equal to integral 0 to pi dx by 1 plus negative power, bring it down, 1 by 5 raised to cos x. Take 5 raised to cos x LCM. So I equal to integral 0 to pi dx we have. You are taking LCM, denominator you take LCM what? 5 raised to cos x. And after taking that LCM, you take it to the numerator, okay? So we have taken LCM. So what you get here? 5 raised to cos x plus 1. That is equation number 2. Now we are adding 1 and 2. The both left sides are I. So I plus I, you will get 2i. Same integral, limit 0 to pi only. See the denominator, 5 raised to cos x plus 1. Here also 5 raised to cos x plus 1. Only order change, right? Or 1 plus 5 raised to cos x. So LCM 1 plus 5 raised to cos x. Numerator just add it. In equation 1, the numerator is nothing, 1. In the second, the numerator is 5 raised to cos x. 1 plus 5 raised to cos x of dx. Cancel both. So you are getting integral 0 to pi dx. Integral 1 integration is x, right? 0 to pi. So your answer is pi minus 0. It is pi. This is the answer for what? 2i. We want to find I value. So I equal to pi by 2. And that is option number 2. Sorry, option number 1. So it is 2i. Sometimes what happens after getting this pi, we may think the answer is what? Pi, second option. No, this is 2i is equal to pi. So I equal to pi by 2. So first 10 questions I've taught in this video. The remaining 10 I'll teach in my next video. We'll continue the next class.